Hello everyone. In this particular video, we will talk about parity, which is one of the most interesting topics in number theory. So, it's in fact not even a topic of number theory. It's often known as heuristics. Heuristics in mathematics. So there is a fantastic book called Problem Solving Strategies. This is by Arthur Angel. You should look this up online. This has some very nice problems from parity, and then there is mathematical circles for kids, which also has problems from parity. So the basic idea is very simple, that odd is not equal to even. I mean, this almost sounds trivial, right? But surprisingly enough, this particular idea that odd, if you can show a particular quantity to be odd and even at the same time, then you find a contradiction, and many problems can be solved beautifully using this very simple idea. So let's see an example. The first example is really simple. It's a 22 integers problem. So this problem is like this. There are 22 integers. Maybe I can use a different color. Let me use red here. There are 22 integers and their product is given to be 1. So if integers means I'm allowing positive and negative integers. Positive and negative integers. Now if their product is 1, you can easily understand that they are either 1 or minus 1. Each of these 22 integers can be either 1 or minus 1. And we want to show that their sum cannot be 0. Sum of these 22 integers cannot be 0. Now this is a very simple problem. It will just give you a taste of why parity can be really interesting. So I want to give this problem to you as a challenge problem. Think about it and put a comment in the description using odd and evenness to prove this fact. It's very easy. I mean, you can just, I think you'll be able to solve it within few minutes. The real problem that we want to solve today is the grasshopper problem. Okay, what is it? So a grasshopper jumps along a line. So there will be a line like this, and the grasshopper is jumping along this line, maybe left or right. So there are two directions. One is right, one is left. The first jump takes him 1 centimeter. The second jump takes him 2 centimeters. So in other words, fifth jump is 5 centimeters long. 5 centimeters long. So 11th jump is 11 centimeters long, and so on. Suppose it has jumped 1985 times. It has jumped 1985 times. So the only thing that you do not have control on is whether it is jumping left or right. You do not have a control on the direction of the jump. So direction independent. So it can jump right or left. Okay. So the question is, after 1985 jumps, can it return to its original position, the starting position? So let's look at an example. Instead of 1985 jumps, let's start with 3 jumps. Okay. So after 3 jumps, can the grasshopper come back to its original position? Suppose it starts at the point 0. So this is the bird or the grasshopper, and it starts at 0. In the first step, so this is step 1, it goes right. So of course it moves 1 unit to the right, so it goes right. Step 2, from this position at 1, it's at 1 right now, it jumps right again. So again jump right. So it's now at position 3, because at step 2 it must go 2 unit. Step 3, it takes 3 units. Obviously third step means it will move 3 centimeters, but let it jump left right now. So it goes back, this grasshopper goes back to the original position, the starting position, because this particular jump was 3 centimeters long. And clearly 1 plus 2, if plus denotes the right moves, so plus 1, which is a right move, plus 2, which is again a right move, minus 3, which is a left move, is 0. So the problem asks that whether it's, so for 3 jumps it can definitely come back to its original position. If it goes right, right and then left, it can come back to its original position. The real question is, can it do this with 1985 jumps? So you really see the problem here now, that in the first step, so maybe I can go to a new board. So in the first step, the grasshopper goes 1 centimeter. In the second step, it goes 2 centimeters. In the third step, 3 centimeters. Like this in the 1984th step, 1984 centimeters. 1985, fifth step, 1985 centimeters. What you really want to do, maybe I can change the color here a little bit. So let me use green. You want to plug in plus or minuses here. Plus meaning right move, minus meaning left move. So you want to put plus and minuses, and you want this sum to be 0. That's your goal. Now let's see how we can solve this problem. You see, this number 0, this number is a even number. This is an even number, right? This is an even number. So if we can show that whatever we do, the left hand side will always be odd. If we can show that the left hand side is always odd, then we are done, because odd cannot be equal to even. So the answer will be no, it cannot come back to its original position, 0 being the starting position, the original position. And it can never come back because whatever the symbols you place, plus or minuses here, the output will always be odd. If we can show that, then in a way we will be done. So let's see how that can be done using a simpler, much simpler demo example. So instead of 1985, let's use 5. So that will reflect the actual idea. If you take 1, 2, 3, 4, 5, and there are plus and minuses, plus and minuses, plus and minuses, plus and minuses, plus and minuses. You want to know whether this can be 0. Now notice that this is even. Suppose one of these things is a negative. So we will only focus on the negatives, the negative numbers. All of them cannot be positive because the sum cannot be 0. So some of them will be negative. For the sake of illustration, suppose this is negative and this one is negative. So we have a -2 and a -5. This is just an example. I want to convert this -2 into a +2. So to do that, I'll add 2 times 2. And to convert this -5 into a +5, I will add 2 times 5. So when I add 2 times 2 to the left, I'll add 2 times 2 to the right, keeping the equality active. And when I add 2 times 5 to the left, I'll also add 2 times 5 to the right. So balancing out both sides of the equation. Now notice that you are adding 2 times a number every time to the right hand side. So it will stay even. So if you were adding, maybe I can write it like this, adding 2 times a number to the right keeps it even, because you started off with 0, which was an even number, and then you have 2 times something, and then you again add 2 times something. So at every step, this particular thing on the right hand side remains even. What happens to the left hand side? At some point, all negatives will be converted to positives, So what will we have? We have 1 plus 2 plus 3 plus 4 plus 5 on the left hand side equal to something even on the right hand side. And we have found a contradiction, because this is 15, which is odd. So this number on the left hand side cannot be equal to the number on the right hand side. So in the beginning, the parity of the left hand side was odd and the right hand side was even. So there is a contradiction. So no matter how you put the pluses and minuses, you can never be equal to 0 for the case of 5 jumps. Can you show this for 1985 jumps? So you can put this in the comment in the description, and keep on doing great mathematics and using parity for solving problems. I'll see you in the next one.